Discovery and innovation have been an integral part of scientific inquiry since the beginning of human history. Their relevance to Air Force research is based upon a simple premise: find more effective ways to keep airmen healthy and fit that maximizes warfighter performance and survival. Brooks Air Force Base in San Antonio, Texas, was home to a community of visionaries. Their ingenuity and initiative led to the creation of medical wonders and marvels that have had a profound impact on humanity. The wonders and marvels produced at Brooks would not have been possible without military innovators' commitment to the Air Force's primary mission of national defense. Such support created a nurturing environment that promoted scientific achievement. Scientific investigations contributed to the Air Force's development of medical wonders and marvels. These investigations explored possible solutions to potential life-threatening and quality-of-life impeding physiological problems. One of the most important physiological issues to airmen, the need for supplemental oxygen at higher altitudes, had been a persistent problem since the days of open cockpit-powered flight. During the World War I era, airborne pilots used a short rubber hose connected to a pipe-stem device to breathe. While the invention of the oxygen mask made breathing at higher altitudes less challenging, this technology had its limitations.
Physiologically, we could only keep the blood saturated to about 28,000 feet. And what happens, of course, if you continue up, it's just like getting drunk and you don't have any control. You think you're great all the way through until you kill yourself. That's about the answer there. So that was a tremendous limitation.
Dr. Forrest Bird found an innovative solution to such limitations by modifying oxygen delivery to air crews. As an Army Air Corps technical air training officer serving in World War II, this Massachusetts-born physician-scientist made an unanticipated journey of discovery. Dr. Bird discovered that aircraft oxygen equipment needed improvement. His initiative to modify military oxygen equipment had laid the foundation for future innovation. Consequently, such modifications ultimately contributed to Dr. Bird's inventions that have saved the lives of countless people throughout the world. His task then appeared daunting. Prior to and during World War II, aircraft technological advances had exceeded altitudes at which pilots could breathe unaided. At the time, turbocharging airplane engines allowed fighters and bombers to fly higher and faster.
Oxygen was a problem, and just at that time we were getting our new B-17s and B-24s and P-38s. Those aircraft would go to 35 or 40,000 feet. And we had a problem. We could only go to 28,000 feet physiologically. And the reason for that is we had what you see in an airline today, the drop-down mask, and you'd put it over, it had a little bag on it. Only our bag had oxygen in it. That was the only difference. And we'd breathe that.
Serving with the Army Air Corps' Air Transport Command, Dr. Bird experimented with positive pressure breathing using existing aircrew equipment.
I picked up this airplane. It had kind of a round breathing. It said demand regulator on it, and then it had a tube, fairly good-sized tube coming out, a nice-fitting mask. And of course, I didn't have any. It's a long trip across the North Atlantic, hour after hour. So I started playing with it almost immediately out of England, and I finally ran out of oxygen. I didn't get high enough to really need on. But the only problem was you had to suck your guts out to get the oxygen to release.
Dr. Bird flight tested a military oxygen breathing regulator he converted into the world's first intermittent positive pressure breathing device. The modified device pushed oxygen into the lungs. The device he modified was originally designed for manually pulling oxygen into the lungs. Dr. Bird's work with oxygen regulators led him to produce another important device for aircrew survival. It ultimately resulted in his invention of one of the greatest medical marvels in history. Working with Dr. Earl Wood at the Mayo Clinic in Rochester, Minnesota, Dr. Bird created the magnetic anti-G pressure suit regulator. The device helped prevent pilot blackouts during combat maneuvers, what is called G-force-induced loss of consciousness. So successful was this device that a colleague convinced him to make a clinical respirator out of the anti-G suit regulator. By 1955, Dr. Bird had introduced to the world his signature invention, the first reliable, low-cost, mass-produced medical respirator for acute and chronic cardiopulmonary care. Named the Mark VII respirator, millions of Americans knew it simply by what TV show physician Dr. James Kildare called it when he needed it during a medical emergency: the bird.
I can remember as an intern and a resident, and I'm somebody going into pulmonary failure that's on death's door. And I'm crying out, give me a bird respirator, and bring that bird respirator. It was like a transformation of life. I'd save that patient's life, and I did it more than once.
The bird respirator revolutionized respiratory therapy. The device that preceded it, the iron lung, had its limitations as a breathing machine for polio patients.
The lucky ones, if one can affirm in the positive, those children stricken with infantile paralysis, survived the polio epidemic with courage and determination. They fought the good fight against a devastatingly cruel disease that robbed them of any carefree days, along with the freedom of independent movement. The less fortunate ones accepted their fate, confined within cumbersome iron lungs that mechanically ventilated their lungs to help them breathe. These devices prolonged life, but limited mobility. Paralytic polio was a constant companion to those who struggled to survive a suffocating and indiscriminate disease. Jack Judson.
Dr. Bird's respirator was the first device designed for patients with obstructive pulmonary disease, such as emphysema. In 1969, Dr. Bird adapted his respirator for babies born with respiratory problems, made worse by the technology of the time, small oxygen tents. The tents were notoriously ineffective in regulating oxygen levels. As a consequence, too little oxygen administered through the tents left some infants with irreversible blindness. Many did not survive, victims of oxygen toxicity. The Baby Bird respirator resolved the problem. As a result, the device contributed to a dramatic reduction in the infant mortality rate, from 70% to 10%. Dr. Bird's medical wonder was specifically designed to breathe for premature babies suffering from cardiopulmonary problems without damaging the lungs.
Blake was born with his lungs weren't developed at all. And the only thing that saved Blake's life was the Bird respirator. They would try to wean him off. The Bird respirator was a fragile unit that would supply Blake with the right amount of air without collapsing his lungs.
Brooks Air Force Base's support to Dr. Bird's medical marvels involved testing. All breathing devices developed by Dr. Bird were first evaluated at Wilford Hall Medical Center in San Antonio, which was part of the Aerospace Medical Division headquartered at Brooks. Brooks' leadership, who allowed access to Air Force research facilities that tested these medical devices, had displayed the same confidence in Dr. Bird's capabilities as that conveyed to him by Dr. Harry Armstrong. It was General Armstrong, founder of the Aerospace Medical Division, who in 1945 had listened to Dr. Bird describe his modification to an Army Air Corps oxygen breathing regulator. The Bird-modified device had transformed how air crews received oxygen at higher altitudes through positive pressure breathing. Brooks scientists also contributed immeasurably to advances in oxygen therapy. Modern hyperbaric medicine owes its development to the pioneering work of the U.S. Air Force School of Aerospace Medicine. Their work led to a revival in the use of hyperbaric oxygen therapy that had its roots in centuries-old research on Caisson's disease, also known as the bends. Decompression sickness had been the scourge of deep-sea divers, mountain climbers, and balloonists for centuries. They suffered physiologically when nitrogen dissolved in the blood was released rapidly during abrupt changes in pressure. The condition earned its name, Caisson's disease, during the building of the Panama Canal. Crews working in caissons, or underwater work chambers, experienced excruciating pain when nitrogen bubbling in their veins sought release under pressure at depth. The condition caused victims to contort or bend their bodies in agony. The Panama Canal Company used a small decompression chamber, moored to a floating barge, to treat caisson workers. While aviation medicine was in its infancy, civilian hyperbaric medicine flourished from 1928 to 1937. physicians used oxygen to treat a variety of ailments. The impetus for developing hyperbaric oxygen therapies in the Air Force was operationally inspired. From World War II to 1959, 18 fatalities were caused by decompression sickness at altitude. Another 743 cases were impacted by its health-impairing and potentially life-threatening effects.
It was an operational issue they had to deal with. They were crippling people with high altitude, unpressurized flight during the Second World War, and then in loss of aircraft pressurization in the 50s, 60s time period, seeing more and more of the cases of decompression sickness. So it was something they had to solve. And at the time, the doctors couldn't decide how best to treat this. That's why Brooks became so important, because they end up installing the research chamber here at Brooks that resulted in the studies that convinced the world that one should treat altitude decompression sickness the same way you treat diving decompression sickness.
The American medical community had lost interest in hyperbaric oxygen's therapeutic potential by the time the Air Force launched the medical specialties revival in 1960. The Air Force's first successful hyperbaric oxygen treatment in 1959 of a pilot suffering from decompression sickness at Langley Air Force Base, Virginia, led to the creation of a research and treatment center for hyperbaric medicine at Brooks Air Force Base. The Brooks Center fulfilled a great need for emergency care in America, especially for people living in the South and Southwest. In the early 1960s, the only American civilian decompression chambers available for emergency hyperbaric treatment were located at the Harvard School of Public Health in Boston, Massachusetts, the Mayo Clinic in Rochester, Minnesota, and the Panama Canal Company's Salvage and Depot Diving School in the Canal Zone. Air Force hyperbaric medicine owes its development to the vision and dedication of Missouri native Dr. Jefferson C. Davis. Through his research in the application of hyperbaric oxygen, Dr. Davis pioneered its use in the treatment of decompression sickness and air in the bloodstream called air embolism. His innovative work helped save the lives of countless military and civilian divers. In 1974, Dr. Davis founded the Air Force Hyperbaric Medicine Center at Brooks Air Force Base. It was there where he conceived, implemented, and established the first major program in the United States to apply and study the therapeutic effects of hyperbaric oxygen.
The Brooks Center was created in a time, consider the environment. A lot of money was spent on research under deep sea exploration and for space exploration. And we now had an environment where divers and aviators and astronauts were exposed to an environment where decompression sickness was not only a possibility, but a very likely event. And so it became a very important role for Brooks to be involved in that. Well, when the Hyperbaric Center was created, it expanded that role to not only look at those operational issues, but also to look at the possibility that war injuries would be benefited from it.
What had begun as an Air Force program designed to treat aviators victimized by decompression sickness had blossomed by the 1970s into a clinical research juggernaut. Hyperbaric medicine research at Brooks provided hope and effective remedies for patients who otherwise could no longer be helped by surgery or antibiotics. Hyperbaric oxygen, administered at pressure higher than normal atmospheric pressure, became the standard treatment option for a variety of medical conditions. Subsequent Air Force innovations spawned advances in the treatment of non-healing wounds, carbon monoxide poisoning, air embolism, bacterial gas gangrene, crush injuries, bone infections, anemia, radiation treatment-induced tissue necrosis, compromised skin grafts, thermal burns, and destructive soft tissue infections. Led by Dr. Davis, Air Force researchers created such hyperbaric medicine marvels as abdomen wound molds for topical oxygen treatment, leg and arm bags used to treat extremities and joints affected by decompression sickness, and an infant treatment chamber. They also developed new oxygen therapies and delivery systems. Brooks hyperbaric medicine research has helped save the lives of dead-end patients, people who are critically in danger of losing limbs such as diabetics. Air Force physiologists Paul Sheffield and Tom Workman developed non-invasive transcutaneous oxygen tension measurement techniques. These techniques help physicians determine optimal times for surgical amputations in patients whose wounds do not heal. Today, Air Force hyperbaric medical research is playing a greater role in helping America's warfighters recover from combat-related injuries. In recent years, Air Force medical research has focused on the use of hyperbaric oxygen to treat acute traumatic injuries sustained on the battlefield. The vision that Air Force hyperbaric medicine clinicians demonstrated in finding innovative ways to treat a variety of medical conditions was also shared by other Brooks scientists. However, they focused on another type of vision: eyesight. Among their concerns was myopia, the nearsightedness that plagues a quarter of American adults. In the years before an enterprising Brooks physicist discovered a new method to effectively correct myopia, this condition prevented airmen from becoming pilots. The surgical eye procedure that existed at the time, radiokeratotomy, used diamond blades to remove tissue from the cornea. However, this procedure, developed in 1898 and improved in the 1960s, wasn't optimally effective in correcting myopia. Since then, more than 2 million people worldwide have had corrective eye surgery. Most of them have benefited from new medical wonders that Air Force vision science research produced. None of them know that a Brooks bioeffects study on lasers used for naval submarine communications led to an Air Force scientist's discovery of a unique and unexpected way to correct nearsightedness.
The whole impetus for conducting this study was the naval laboratory's interest in communicating with submarines. And at that time they were using green light as a source of communication. One of the most promising green light sources was the light source that was generated by using extreme UV light to pump the source to generate green light.
Working with powerful excimer lasers, Dr. John Taboada achieved a medical breakthrough in 1978 while working for the School of Aerospace Medicine. The world's first excimer laser exposure of living eye tissue produced a dramatic result.
I observed that there was an unusual excavating effect. The laser left an indentation on the cornea. But the incredible thing is that this indentation, 2 or 3 hours later, was gone. It disappeared.
Dr. Taboada had discovered the non-damaging, self-healing, laser-induced resurfacing of the cornea, called photorefractive keratotomy, or PRK. Dr. Taboada realized that PRK was a significant discovery that would transform corrective eye surgery. His discovery also proved that extreme ultraviolet light created by an excimer laser to produce PRK was safer than other types of laser surgery.
Laser surgery at that time was being done with CO2 lasers, infrared lasers. They were mostly associated with heat and cutting and burning. No one thought at that time that you could get a similar effect by going to the extreme other direction, toward the UV light. For one, you would always have the fear of UV light being carcinogenic, like the sun would cause skin cancer. Well, this laser would just simply be zapping you absolutely right down the pike with the maximum amount of light in that wavelength band. There were no thresholds, no safety standards. There were no known values for damage levels as far as the effect of that laser radiation on the cornea. So it was up to our laboratory experiment that my colleagues and I set up to explore.
PRK is considered today to be superior to the diamond blade incisions used in radiokeratotomy surgery to correct myopia. The U.S. Food and Drug Administration approved PRK in 1995. The Air Force approved it in 2001. PRK helped the Air Force retain many of its aviators who had previously suffered from nearsightedness. Before the advent of PRK, no one was accepted for flight training who had myopia. PRK also provides other advantages for airmen who have used it to correct vision.
Doing PRK removes the requirement for spectacles, which is a great advantage when you have individuals working within a helmeted environment, behind visors with night vision devices or whatever equipment is being worn. But if you also think about the advantage that PRK gives our special operators, for example, required to use perhaps visual devices, night vision goggles, visor-mounted devices, and so forth, but it gives them the advantage of not requiring spectacles.
More important to the public, PRK's use of laser energy to remove small amounts of corneal tissue contributed to the development of LASIK surgery. Both LASIK and PRK permanently changed the shape of the anterior central cornea through tissue removal using excimer lasers. The PRK procedure greatly enhanced the speed and postoperative results of corrective eye surgery.
The operation itself took all of about 2 minutes, extremely fast. You walk in, he lays you down on a table and he puts the laser over your eye. You hear some clicking noises, which is just the laser going off. And I think it was about 45 seconds per eye. And when the doc said, okay, you can sit up in the chair, I sat up in the chair and he said, now read the clock on the wall. And I looked at it, boom, just like that. Could read it.
Even more profound in its application to public health was the groundbreaking work Brooks scientists made to help mitigate the effects of cardiovascular disease. The #1 cause of death and disability in America today, cardiovascular disease had been detected in military pilots since the dawn of the jet age. The problem had surfaced before the U.S. Air Force School of Aerospace Medicine inaugurated in 1957 the medical evaluation of grounded pilots at Brooks Air Force Base. Dr. Lawrence Lamb was at the forefront of Air Force cardiovascular disease research. During the 1950s, he knew something had to be done about medicine's limitations for early detection of cardiovascular disease. Dr. Lamb's quest to develop preventive medicine countermeasures was rooted to a shocking discovery in 1955. Half of Air Force aviators had cardiovascular disease. This discovery prompted the Air Force to launch in 1956 the world's longest-running study on the long-term effects of heart disease in men. This landmark West Point study medically monitored for decades U.S. Military Academy graduates for coronary heart disease. 474 West Point graduates from the class of 1956 volunteered for the study. The study focused on certain risk factors for cardiovascular disease, including high cholesterol levels, smoking, and lack of exercise. In 1992, 387 volunteers from the original study group underwent a final cardiac evaluation at Brooks Air Force Base. Those in the group who had cardiovascular disease helped validate the study's goal to identify and correlate specific risk factors for heart disease. The West Point study helped the Air Force to identify potential heart disease candidates at a young age and help them reduce their risk. The Air Force's Health Evaluation and Risk Tabulation Program, nicknamed HEART, also contributed to early diagnosis of heart attacks and strokes in flying personnel. The study provided the basis for new effective health dietary programs that benefited both the military and civilian community. Among other Air Force contributions to cardiology are the School of Aerospace Medicine scientists' discovery of electromagnetic interference affecting cardiac pacemakers, the invention of the portable heart monitor, discovery of the metal stress-induced hormone cortisol as a risk factor for coronary artery disease, and development of an effective means of detecting latent asymptomatic coronary artery disease through innovative application of radioisotopes. One of the greatest contributions that the Air Force made to cardiology involved the artificial heart. The invention by Dr. Robert Jarvik of the Jarvik 7 artificial heart owes its development to a Brooks scientist, Dr. John Taboada. Dr. Jarvik invoked Dr. Taboada's patent on a magnetically accentuated sealless glass pump as the primary foundation for the design of Jarvik's invention. The Jarvik 7, the world's first permanently implantable artificial heart, has helped extend the lives of countless patients. When it debuted in 1982, the Jarvik 7 became a bridge to heart transplantation. It gave cardiac patients time to survive long enough to receive a new heart. Surviving long enough, through the detection of disease, was at the heart of a young Air Force captain's research when his discovery resulted in his invention of one of the greatest technological marvels in history. New York City-born physician-scientist Dr. Raymond Damadian couldn't have intuitively known that his discovery would forever transform modern medicine. While working for the Air Force School of Aerospace Medicine at Brooks Air Force Base from 1965 to 1967, his biochemistry studies led him to adapt existing technology for a greater purpose. Dr. Damadian became the first person in medical history to use nuclear magnetic resonance to image living tissue. Nuclear magnetic resonance, or NMR, is a phenomenon of atomic nuclei emitting radio waves at predictable frequencies when exposed to a powerful magnet. It had been used during and after World War II to probe the composition of various substances. No one, however, had thought to use nuclear magnetic resonance as an imaging medium for the human body.
I know that cancer tissue has an abnormal sodium-potassium ion composition. And in my work, in the laboratory work on this whole phenomenon, Freeman, I've never seen a case where the sodium-potassium composition of the cell changes without the water composition changing with it. And Freeman, the water is something I can easily measure on NMR, because nuclear magnetic resonance, the atom it was looking at in the hands of the chemists almost exclusively was hydrogen. And hydrogen is the principal component of H2O, so I knew, and everybody knew, that getting a signal from water on the inside of tissue was going to be easy. On the basis of what I know, that the ion composition is abnormal, I'm expecting that water signal in cancer tissue will be abnormal. And I said, if we can do that, if I can show that the cancer signal is abnormal relative to the normal signal, then I have a signal that we can non-invasively scan the human body for to locate and identify cancer deposits in the body wherever they might be located.
Dr. Damadian invented an apparatus and method to use NMR safely and accurately to scan the human body. He called the method MRI, short for magnetic resonance imaging. After leaving the Air Force, Dr. Damadian patented the world's first MRI machine in 1972. In 1977, Dr. Damadian and his scientific team produced the world's first MRI scan of the human body, using a prototype device called Indomitable. This historic device, the first MRI scanner, is now part of the Smithsonian Institution's collection.
Okay, this is Larry Minkoff, and he was a gentleman kind enough to generate the world's first human MRI of a live human being.
In 1978, Dr. Damadian founded the Phonar Corporation, which produced the world's first commercial MRI scanner in 1980. Today, the MRI medical scanner that Dr. Damadian invented instantly maps and analyzes any part of the human body, allowing visual diagnosis of virtually any medical condition, from strained muscles to tumors. Dr. Damadian's invention is the preferred imaging method used in medicine today. MRI scanners provide good contrast between different soft tissues. This makes MRI scans especially useful in imaging the brain, muscles, the heart, and cancers, compared with X-rays and computed tomography or CT scans that use harmful ionizing radiation.
What was missing, which the NMR provided, was the ability to distinguish soft tissues, the ability to distinguish one soft tissue from another. And in the vast majority of cases in medicine, that's exactly what the physician must distinguish. He must distinguish a soft tissue tumor in the brain from the surrounding brain. And that's what the X-ray was singularly incapable of doing.
President Ronald Reagan awarded Dr. Damadian the National Medal of Technology in 1988 for independent contributions in conceiving and developing the application of magnetic resonance technology to medical uses, including whole-body scanning and diagnostic imaging. His MRI technology contributions, including collaboration with heart pacemaker pioneer Wilson Greatbatch that led to MRI-compatible pacemakers and defibrillators, earned Dr. Damadian a 2003 Nobel Prize nomination. The wonders and marvels produced through Air